Recursive formulas. Okay, so far we have learned the explicit formulas for sequences. Our arithmetic explicit formula looks like this. A sub 1 plus d times n minus 1. And our geometric, right here, a sub 1 times r to the n minus 1. So those are explicit formulas. It's easy to find terms in this way because if I want the, if I wanted the 117th term, I just plug 117 in for n, and I've got the term. Now we're going to look at recursive rules. Here, you have to write out all the terms before 117 in order to know what the 117th term is. So, our recursive formula for arithmetic looks like this. A sub n equals a sub n minus 1, that means previous term, plus your common difference. So we're taking the term before, we're adding the common difference to it, and we get our current term. For geometric, we're taking r times a sub n minus 1. So we're taking our previous term, a sub n minus 1, we're multiplying r by it to get our next term. Okay, write the first 6 terms of the sequence where a sub 1 is 1, and then a sub n equals my previous term plus 4. So the only way that you can use recursive formulas is if you're given the first term. So every time that you write a recursive formula, you also have to give the first term. So my first term is 1. If I look over here, it says that I'm taking my previous term and adding 4 to it. So I'm going to take my previous term of 1 and I'm going to add 4 to it. I'm going to take my previous term of 5 and I'm going to add 4 to it. My previous term of 9, I'm going to add 13 to it. Add 4 to it and I get 13. And then 17, 21, and there's my first 6 terms. Write the recursive rule for the sequence a sub n equals negative 6 plus 8n. So I've given you an explicit rule. This is explicit. And I'm now wanting to write the recursive rule. So the only way to do this is to see what my sequence is. So I need to write my sequence out. I'm going to write out maybe the first 3 or 4 terms to get an idea of what's going on. So for the first term, I'm going to plug 1 in for n. I get 2. Then I'm going to plug 2 in for n for my second term. I get 10. I'm going to plug 3 in for n. For my third term, I get 18. So now if I look at this sequence here, it looks like I am adding 8 every time. So my sequence is 2, 10, 18, and so on. Okay, so now I can easily write my recursive rule. A sub 1 is 2. I always have to note what my first term is. And then my recursive rule, a sub n equals my previous term, a sub n minus 1, plus 8. So there's my recursive rule. Okay, same idea here, except for now I have geometric going on. So I need to write out the first few terms of my sequence. So my first term I know is negative 3 because it's in the spot where a sub 1 goes. And I'm multiplying by 1/2 every time. So this is going to be negative 3 over 2, negative 3 over 4, and so on. Okay, so now I can write my recursive rule. A sub 1 is negative 3. A sub n equals, now for the recursive part, I'm going to take my previous term times 1/2. And I'm done. Okay, so now I'm given a recursive rule, and I need to write the explicit rule for it. Again, I'm going to write out the first few terms of my sequence to help me. So in this recursive rule, it's telling me that my first term is negative 5. And then it says I take my previous term and I subtract 2. So negative 5 minus 2 would be negative 7. Minus 2 would be negative 9, and so on. So now to write my explicit rule, I have to remember that formula. I'm going to plug negative 5 in for a sub 1. My common difference here is subtracting 2. And now I need to simplify that. So I'm going to distribute the negative 2. Oops. And combine like terms. There's my explicit rule. Okay, same idea here, except now it's geometric because I'm multiplying over here. So write out the first few terms of my sequence. My first term is 10. This says I'm going to take my previous term times 2, so 20, 40, and so on. My explicit rule is going to be my first term times my common ratio, which is 2, to the n minus 1. Pause your video, try the independent practice on your own, and restart it to see my answers. Okay, with this problem, I wrote out a few terms of my sequence, 13, 9, 5, and then I was able to write my recursive formula. Okay, for this problem, I wrote out the first few terms, and then I put it into the arithmetic explicit formula, distributed my 16, combined like terms, and got my final answer.